Hi, welcome back to Science 1206, the motion unit. I'm Miss Ledwell, and in this video, we'll review some important concepts about graphing. Let's get started. First up, let's review the components of a graph. All graphs, including position-time graphs, should include a title. This describes what your graph is about. This will include the dependent and independent variables. Your graph should also include axis labels. They define the data that is being graphed. Always label your axis with the variable and units. The y-axis has the dependent variable, and the x-axis has the independent variable. All graphs, including position-time graphs, should also have uniform scales. Graphs must be uniformly incremented. For example, in multiples of 1, multiples of 2, you could go up by 5s, 10s, or 20. So you can see in this graph on the x-axis, which is time, we have a uniform scale and it went up by 1s. The scale does not have to be the same on both axes, but the scales must accommodate the ranges of the two variables. When you look at your data table, your scale has to incorporate all the numbers in your data table. Also remember that your axes have to be labeled with the variable and the appropriate units. So in this graph, on the y-axis, we have position in meters right, and on the x-axis, we have time, which is the variable, and the units are seconds. The scale you use should allow you to plot all your data on the graph, and the resulting graph should be large enough to be easily read and interpreted. A rule of thumb is that your graph should fill about 75% or more of the available space. Interpolation is used to estimate values between points on a graph. On this graph, for example, if you wanted to estimate the viscosity at a temperature of 55 degrees Celsius, you would use interpolation. So 55 degrees Celsius is not a data point. That's why we have to use interpolation to determine the viscosity at that point. So we'll find 55 degrees Celsius on our x-axis, and then we'll draw a line up to touch our graph. Then we'll draw a line straight across to touch off the y-axis. Using this, I can estimate what the viscosity would be at a temperature of 55 degrees Celsius. I'm just going to read the temperature off where my line met the y-axis. And I would say the viscosity is about 15 centimeters per second at 55 degrees. Next, let's look at extrapolation. Extrapolation allows us to predict values outside the range of our known data points. Using the graph below, if you wanted to determine the concentration of hydrochloric acid at a reaction rate of 160 seconds, you would use extrapolation. To predict the concentration of hydrochloric acid at a reaction rate that is not included in our data, in this case, at a time of 160 seconds, we would first extend the line of best fit beyond the last plotted data point on our graph, like so. So notice the line being extended beyond the last data point. Next, we need to locate 160 seconds on the y-axis. So after we locate 160 seconds, we're going to draw a horizontal line towards the right until it intersects the extended line of best fit. Then we're going to draw a vertical line down to meet our x-axis. The point where this line that we just drew intersects the x-axis corresponds to the estimated hydrochloric acid concentration, and I would estimate it to be about 4%. When data points do not connect to form a straight line on a graph, you do not just connect the dots. This is where a line of best fit is used. A line of best fit follows the general shape of the data points. This line doesn't have to pass through all the dots, but should reflect the general trend. A good line of best fit has roughly equal numbers of points above it and below it, showing the average direction of the data. This is an example of a line of best fit. You'll notice that the dots were not connected, and you have about equal numbers of data points above and below the line, and some the line does pass through. We can see here some data points below the line, some above, and again some below. You just try to have equal numbers above and below the line, and the line will normally pass through some data points. When plotting data, a circle should be placed around each point to indicate that the point is not exact. It indicates that there is a degree of error. Here's an example of that. Now it's time to continue to the next video. Take a brief break, stand up for a quick stretch, then dive into the next video.